yeah, we'll go ahead and start so that we can stay on time. Thanks everybody for coming to this first of 4 sessions. We have approximately 5 people presenting each day. Today we do have 5 presenters, and we're just going to, each presenter will have 15 minutes to give their presentation and then 5 minutes for questions. When we get to the questions, if you can type your questions into the chat, and then when the presenters will then read your question and answer them. And I think that's about it. If anybody has any questions, you can privately chat me, but thanks again. And Matthew's going to be presenting GeoFish web app for Florida saltwater fishing season. So go ahead and start whenever you're ready, Matthew.
Hi, welcome everyone. I'm Matthew Erb, MGIS student at Penn State, presenting the GeoFish web app for Florida saltwater fishing seasons. I will be happy to take questions at the end. Today, I will share with you the following information. We are going to cover background and problem set, goals and objectives, proposed methodology, challenges and improvisations, results, functionality, deficiencies, future application, and our conclusion. All right, Florida saltwater fishing industry. It's time consuming. It can take well over an hour to, we're gonna start with background and problem set. I was looking at the wrong slide. It's time consuming. It can take well over an hour to research the Florida Fish and Wildlife Conservation Commission, FWC, website to find out what fish are in season based on their locations. Hundreds of species and multiple pages to search through can be daunting. Not to mention, there are several different fishing season zones that do not line up for each species. It would be faster and simpler if there were a web app or mobile app to validate which fish are in season and are able to legally keep. From speaking to friends, coworkers, and family, an app such as this would be very popular with fishing enthusiasts, as they all face the same problem. This app would be advantageous for the end user and the state to enforce regulations and would help to keep fish populations appropriate in accordance to legal restrictions. Many times, when people go fishing, they may not do the research nor put the care or effort required, or even be confused by the regulations. By thoroughly researching the internet, there appears to only be one other solution that displays FWC fishing season data and zones by an end user's specific location. The mobile app identified is called Fish Rules. Fish Rules has a major disadvantage in that the end user has to scroll through hundreds of different fish and then click on the fish to find out if it is in or out of season. By the time one would find the fish to determine if it can be kept, the fish may have died from being exposed out of water. This is a true disadvantage to both the fishermen and the current technology on the market today. Florida saltwater fishing industry. Florida has the longest coastline in the continental United States at 1,350 miles, and the 3rd largest population at over 21 million residents. This large population has easy access to the coastline, with no one living over 100 miles to saltwater fishing. Florida also has the 3rd highest number of fishing license holders at over 2 million, just behind California and Texas. FWC estimates the actual number of anglers to be around 4 million if you consider that you don't need a license when you fish with a charter captain. The saltwater fishing industry is estimated to bring in revenue in excess of $9.2 billion and supports approximately 88,500 jobs. Florida is the #1 location in the international game fish records as well. Although owning a boat and fishing gear can be cost prohibitive for many people, you can also fish relatively inexpensively on the shoreline, beaches, and piers the state has to offer. Considering this enormous market, there's a lot of room for a new fishing web app such as GeoFish to gain popularity and carve out a niche for recreational fishing enthusiasts. Goals and objectives. The goal of this project is to build a Florida saltwater fishing web map that is quick and easy to use for the most novice of fishing enthusiasts. An ideal map would allow you to choose your exact location and display a list of out-of-season fish based on the exact date. This will allow the user to glance at it once and decide immediately if he or she is legally allowed to keep it, or should immediately release the fish back into its natural environment. Proposed methodology. In order to keep the project at a manageable scale, the focus is on Florida saltwater fishing only. Data was acquired through the FWC website to build a web map. Additional geospatial data was requested from the FWC in order to avoid manually creating them from PDF maps. ArcGIS Pro software provided by Penn State was used to create the web map. Since there are thousands of aquatic wildlife species in Florida, the ideal method is to display the data on a web map to include only species that are out of season at the user's chosen map location and date. Saltwater species with seasons. Out of hundreds of species, there are only 17 aquatic saltwater species groups that have regulated seasons. You can see in the chart to the left there. Shallow water grouper species include 10 separate grouper species. You can see in the chart to the right. Gag grouper has its own season in the Gulf of Mexico, therefore it's listed twice. Methodology continued. There are 21 geospatial data layers received from the FWC. Some layers were in map packages and others were shapefiles. Of all the layers received, it was determined that only 8 out of the 21 were needed to complete the project. You can see the layers that I used listed in that table. There's 8 of them. Once the geospatial data was received, it did not have all the zones for species separated. The data included statewide boundary lines for the Florida offshore regions. As a result, there was a need for required zones to be traced on the given boundary lines that would include manually drawn separation lines. All right, continuing with methodology. Since there are 17 species with multiple and unique fishing season zones, this ended up to be 37 recorded zones. As depicted to the right, there are many overlapping zone lines for the 17 species and their individual seasons. A spreadsheet was created that had fields for the zone name, species name, start of closed season date, and the end of closed season date. Some species have multiple seasons throughout the year, requiring a field for the start of the second closed season date and the end of the second closed season date. The spreadsheet was then joined to the geospatial layer in ArcGIS. The web map allows everyone who has a web browser with internet access to view it. Challenges and improvisations. Immediate challenges arrived with obtaining data to start the web map. It'd be very difficult and inaccurate to manually draw fishing season zones based on images and PDF documents obtained from the FWC. The pertinent geospatial data was not available on the FWC GIS and mapping data download site, nor was it discoverable on the State of Florida Geographic Data Portal. A formal request for information had to be submitted to the FWC in order for their personnel to retrieve and transfer the geospatial data, which took over 2 months to obtain. Data did not include all zones, tracing, and manual delineation, I can't even say that word, between zones was conducted. Many zones overlap each other with either different areas or different seasons. A few of the species matched within the same zone and season. Those species could be listed together when the attributes popped up. Most of the species did not have matching zones and seasons, so this ended up having to tab through 11 pages on the attribute pop-up upon selecting one location. After a web map proof of concept was created, it was suggested that a web app would be the preferable method to display the map. Results. While developing a web app, widgets were added to create the usefulness. User testing was conducted with several friends, family, and coworkers to understand what better functionality could be added. A splash screen was added with simple instructions on what the app is for and how to use it. It also includes source information, MyWFC or myfwc.com. A filter by date widget was also highly desirable. Instead of seeing an entire year of closed fishing dates, the user can choose a filter option for today's current date. Results continued. And the last widget added and most wanted feature for test users were pictures of the fish. When you click on the information widget, it will display the various species with regulated seasons. All right, so I'm going to do a quick demo of the web app. So I'm going to switch to the screen there. All right, so we'll start with the splash screen here. It tells you what to use this app for. Click OK. Then the first thing you want to do is turn on this filter button. This isn't by default. You have to click this on for closed fishing seasons for today's date. Close that. Then if you're already on the water, you can hit the My Location button and it'll should zoom in there. Well, it was working earlier, but that would take you to your exact location. Then if you want to, you can manually zoom to where you are or where you want to fish. And you can click that location. Then I'll pop up the attributes. So these are fish that are out of season right now. Red drum, spotted sea trout. Then you have to click the next page. Red snapper, gag grouper, snook, spiny lobster, and greater amberjack. Those are all out of season. Then the last thing I want to show you is the pictures of fish. You hit the information button and the fish pop up. You have Gulf on the left side and Atlantic on the right side. So there you have it. It's pretty simple to use and quick, so you can determine if you want to keep the fish or not. So I'll go ahead and switch back to my PowerPoint. Let's see, screen 2. Okay. Can everybody see that? I think it looks fine. Okay. We'll go, since we already went over the functionality, we'll go to the next slide, deficiencies. There are dozens of species that are not allowed to be kept any time of year. These species could possibly be listed as another widget pop-up screen on the web app. Another feature fishing enthusiasts need are the species size limitations and bag limits. This would further complicate the attributes pop-up screen, but could be done by adding new fields to the attributes. Another goal was to display all the fish out of season on one pop-up screen. The way the app functions now, you have to tab through up to 7 pages of attributes to see the fish out of season. This is due to overlapping polygons in each location. This could possibly be resolved by creating intersecting polygons for each zone and adding multiple species and seasons on each polygon. Lastly, the web app does not work outside of cellular data range. This could possibly be mitigated by a dedicated mobile app that stores data on the phone for when there is no data feed. Future application. How I envision the future application, I see so much room for expansion. First, convert into a downloadable app in order for the web app to gain wider acceptance among fishing enthusiasts. Ideally, it needs to be converted and made available on the Apple iOS App Store and Google Android Play Store. This should be a free app in order to gain as many users as possible. Research will be done in order to determine if this app can be easily converted from the ArcGIS web app or if the app developer will need to be hired. Second, promote the app. A basic marketing plan could be started by advertising in the FWC saltwater regulations publication and through other Florida fishing websites, a pop-up ad and or Google ad campaigns. Also, a booth at a fishing or boat show could be a practical site to acquire more users. Finally, business cards and flyers could be left at fishing and bait stores around the state of Florida. Last, expansion. If the app use gains traction, it would be wise to expand it to use in additional states. There are plenty of other states that have confusing fishing regulations and could easily benefit from this technology. More room for growth is available in freshwater fishing as well. This would be especially popular in landlocked states and northern bodies of water, such as the Great Lakes. Lastly, hunting regulations are also confusing, and there are no good apps on the market for hunting as well. Conclusion. There's a niche for a saltwater fishing regulation app, and the GeoFish app meets the need. GeoFish achieves its goal in being a simple app with just a few clicks to see which fish are out of season for a specific location and date. There are improvements needed to make it better, but which can be resolved through further research and development. A more refined app could become the go-to app for saltwater fishing enthusiasts and beyond. The app helps protect overfished species while keeping fishing enthusiasts confident that they are staying out of trouble with the law. I would like to recognize my advisor, Ryan Baxter, for his assistance in keeping me on track, even when there are lots of snags in the road. And thank you to the Florida Fish and Wildlife Conservation Commission for providing all the data needed. I'll take your questions from here.
Great job, Matthew. It looks like you already have a question.
Travis says, was your application pulling in a dynamic table for fishing seasons? Have you thought about using some type of notification by user location, like geofencing or something? I wonder if it is possible to integrate Esri deep learning for species identification. First, with the dynamic table, no, it's not dynamic. I have to manually update the season dates. So if in 2022, I'll have to put in new dates for that. I'm not sure how I could make it dynamic. Have you thought about using some type of notifications to the user? I think that'd be pretty cool if we could send them notifications. I'm not really sure how to do that either, but maybe I can research that. And deep learning, I'm not aware of anything about deep learning. I haven't read up on that, but yeah, all interesting things to be aware of. Thanks. Any other questions? All right, Ryan says, how might your approach to this app be different if you targeted freshwater species? It's kind of the reverse for the polygons. Like I basically drew all around the state, so the freshwater will be within the state lines where freshwater is, and I believe it'd be easier. I think the regulations are much fewer on freshwater because they're not as overfished as the saltwater fish. There's fewer freshwater fishermen in Florida. Then Beth says, has the FWC shown any interest in the app? I did mention to them that I wanted to present this app to them, but I think I was speaking to kind of a lower level employee and they didn't really say anything about it. So maybe I need to contact one of the managers or something, see if they'd be interested. And Fritz says, this is a very practical tool for the fishing enthusiast. Did you consider including the specific rules and regs for fishing in these waters and include the penalties for violating said rules and regs? Yes, I did put well, just for the seasons, the specific rules that I do want to add, like the size limits and the bag limits as well on the app. I just need to figure out if it would fit in there on one page and include the penalties and violations. That might be a good widget to add as well, the penalties and violations, because a lot of people don't realize you can get in big trouble catching fish out of season. Blake says, did you look at other web mapping options outside of Esri products? Assuming it was picked because of all in one package. No, I just went straight to Esri. That's what I'm most familiar with. But if I want to create an actual app that you download on your phone, I'll probably look at other products as well. And I think that's about time's up.
Well,
Anything
clearly,
else?
yeah, great job, Matthew. Clearly lots of interest, and it looks like you could really take this pretty far with lots of different things to add to it if you chose to do so.
Yeah, thank you.
Yep, nice job. Okay, Amy Farley is next. She's going to be giving open source serverless web mapping, a case study for the agriculture industry. So Amy, you can start whenever you're ready.
Okay, good afternoon, everybody. Thank you all for your time today. Again, I'm Amy Farley, and today I'll be talking to you about open source serverless web mapping using the agriculture industry as a case study. In this presentation, I'll start by providing the context around a project I completed, and then I'll dive into the technical details of it. So let me start by just telling you a little bit about myself. I have been a software developer for over 20 years. I have spent many years doing web application development, including web mapping applications using open source frameworks. I've been involved in cloud migration projects, moving infrastructure and software to the cloud. Academically, during this master's program, I've completed coursework focusing on web programming and cloud-based GIS. And as for the ag industry, while I am not the agronomist, I know and have interviewed people in the industry. What exactly did I set out to achieve? The end goal was to build out in a very specific way a proof of concept web mapping software application. This application had to be complete with data storage, hosted in the cloud, but built using only readily available cloud computing services, which means no virtual machines at all. Also, the web mapping interface was to be built using only open source code libraries and frameworks. This project really represents a convergence of technology and industries happening right now. So it's helpful to go back in history and look at major events in GIS, computing, and agriculture. Like any good presentation for GIS, let's start in 1854 with John Snow's cholera map. Charles Babbage is working on his difference in analytical engines. Oops. And the Homestead Act, encouraging westward migration in exchange for farmland, forced the adaptation of new farming techniques to combat the harsh conditions of the American frontier. 100 years later, we are entering the digital age. We see GIS software taking shape and the early phases of satellite-based navigation. At the same time, we have the beginning of the internet. GIS was introduced to the ag industry in the 1980s. This led to the birth of precision agriculture. Once GPS receivers on farm equipment, like this one, became more common, more farmers began adopting these new practices. In the 2000s, the timelines begin to blur and advancements accelerate at lightning speed. Relative to aspects of this project, We have events around the adoption of open source, interactive mapping, and the earliest offerings of cloud computing. All the while, in agriculture, various companies are producing products for capturing information collected from fields and farm equipment. All of these events lead us to where we are now. Today, the agriculture industry is being inundated with data coming from a variety of sources, including satellite and drone imagery, GPS sensors on farm equipment, and field and weather sensors. In computing, cloud computing service models have expanded from the original infrastructure as a service model to models that include services that allow users to truly take advantage of the cost reduction and elasticity benefits of cloud computing. Serverless is truly a pay-as-you-go model. Resources to run the code are provisioned and scaled up and down automatically by the cloud computing provider. Users only pay for resources used while the code is running. And we do have GIS solutions that include web mapping applications hosted on cloud platforms. But the tendency is to continue using a traditional architecture and provisioning that infrastructure. Now, why is this worth pursuing? As we saw in the timeline slides, we are at a unique time where GIS, computing, and agriculture technologies are converging. Modern cloud computing and open source democratize technology and make GIS solutions more accessible. Before going into what I did and how I did it, let me show a quick demonstration of the prototype. It has the usual functionality one would expect from a web mapping application. Features can be searched and displayed on a web map. Users can pan and zoom. Attributes on the geometry can be edited. Non-spatial data can be added. In this example, field activity records are being added and associated back to the geographic feature. Files can be uploaded and associated with database records. Those files that can then be retrieved and viewed. And, of course, new geographic features can be drawn and added to the database. All the typical stuff. What makes this web mapping application unique is the way it has been constructed. Instead of the traditional architecture where each piece requires infrastructure reservation, the architecture looks like this. I used Amazon Web Services as the cloud computing provider. No infrastructure was provisioned. Only readily available cloud services were used. I wrote AWS Lambda functions to pass data between data storage and user interface. The user interface is written using open source frameworks and libraries. Let's get into the technical details. I'm going to cover the key aspects of putting this type of application together. However, there are prerequisites and general configuration required. Start at the main README of the GitHub repository for those instructions. If you reuse this code, you will have to complete these initial instructions before diving into the application-specific steps that I'm about to preview. Now, starting with the application's data storage, two main services are used, Amazon RDS and Amazon S3. Geographic features and attributes are stored in the database. Uploaded files are stored in the S3 bucket. Amazon RDS has a Postgres option with the ability to load the PostGIS extensions. Now, it's worth noting that Amazon RDS is not technically serverless, but still, I did not have to provision the underlying infrastructure. There is a way to make the database truly serverless using a completely different service. And finally, lesson learned during this project: for the file uploads, you use a Lambda function to obtain a pre-signed URL for the application to use for uploads to the S3 bucket. Comprehensive configuration instructions and scripts for creating this application schema are in GitHub. A few main details to point out though. PostGIS functions are used liberally in the schema creation script and in the SQL contained in the Lambda functions. The geographic data needs to be stored in the unprojected coordinate system. Leaflet used in the user interface expects the data to be unprojected and will reproject it on the fly. The Postgres JSON data type is used for dynamic attributing on each geographic feature. Moving on to the serverless part of the application. Each Lambda function is a very small piece of code written for a very specific task. Amazon API Gateway is the service that manages and directs all HTTP requests from the web interface to the Lambda functions. In the context of serverless applications, this service provides an endpoint for each of the Lambda functions. Data passed between the web application to the API gateway is in the JSON data interchange format. The geographic data being passed is GeoJSON. Using a serverless framework, build out your functions and deploy them as either a collection or individually. I used the AWS Serverless Application Model Framework. It uses a YAML configuration file to drive deployment. This file defines each Lambda function, associated API gateway resources, HTTP methods, and any other necessary properties. Resources like the API gateway endpoints are created automatically upon serverless deployment. Tip: write test cases for every single Lambda function. Test the SQL queries and the JSON being returned. The final piece of the application is what we all see and use. Angular and Bootstrap accommodate multi-platform users. The web mapping part of the interface is developed using the open source Leaflet library. Again, all of my code is in the GitHub code repository. Amazon Route 53 is Amazon's domain name service. My favorite service for this project is AWS Amplify. This service connects to your code repository and redeploys your application every time you check in code. You configure it to replace variables in your code with sensitive information upon deployment. And that leads to my last tip, and this applies especially if you choose to use Amplify. Never, ever check in credentials or other private information. You might get a call from Amazon if you do. So what did I learn and what does the roadmap contain? Overall, positive assessment, but there are things that require more research and mitigation work. Serverless cold starts cause a lag in initial requests to an application after an idle period. In this architecture, geographic feature rendering is being done in the browser by Leaflet. More testing is needed to determine a maximum threshold of features to pass at one time. This project is subject to vendor lock-in right now because the Lambda code is specific to Amazon's compute service. Migrating to a different cloud platform would require refactoring those functions. Affordability remains relative per user. Fluctuations in cost hinge primarily on the amount of data storage required. Looking ahead, a few items on my immediate radar. Several features are missing from the prototype, such as user management, and additional AWS services can be used for tighter security, enterprise-ready features, and even more cost reduction and elasticity. So one more time, the code is available here, and I'll open it up to questions now. So let's see.
Great job, Amy. Anybody have questions? I'll go first while people are typing.
Okay.
I
Okay.
was gonna say a lot of this is over my head. So my very simplistic question is, did you ever get a call from Amazon?
Yes, I did. I did. I was testing something out and I checked in a username and password, and I mean, within like that afternoon, like that happened that morning, and within that afternoon, I got an email that was a little strange, and then I got an actual call, and they said that they were about to close out my account if I didn't take care of that. So
Wow.
if you're using your Amazon, if you're using that particular Amazon service where it's connected to your code repository, never, ever, ever check in private information.
Good to know. There's another question now.
Okay, let me stop sharing so I can see the questions a little bit better. Okay. How do you avoid multiple users and conflicting edits? Is this what you mean by version management? I mean, session management. So that's a great question, and that's actually a very typical issue within any kind of web application. So it's generally handled by the database itself. So it's whichever request comes in, that's what goes first. So that can happen in any application. So the trick is really to figure out, do you want to somehow force like the interface that another user might be using if they are editing that exact same feature to automatically refresh. But that's generally something that's handled by your database backend. Style or Adobe experience. I use the little, so I use Balsamic for my prototypes. And you can actually see if you go to, well, let me quickly share my screen again. If we come here, so if you go into my GitHub repository, I actually do have the mockups in there from when I did this. So you can see some of those in that. But hopefully that answers your question about what I use. And, oh, question from Matt, I missed that. Okay, how much like, I'm great, I'm so glad you asked that question. I can maybe even demonstrate that right now. So it's been a minute since I, did anything on this app. So we'll do a refresh here. And it's generally like a few seconds, so longer than, we're not talking like 30 minutes or anything, but it's a little bit longer than what I think is, so that was a little bit of a lag. And then this one generally gives me, if it's been idle for a minute or two. And the thing is, so you can see I've clicked it, but it still hasn't returned. So there's an example of what we're talking about. Previous coding, what new tech here proved the hardest for you to learn? Hardest. So I stumbled around a bit trying to figure out which serverless framework to use, and I tested out a few different ones. So that was a little bit of a learning curve. Just the cloud computing services was also a lot to take in because there's so many, and understanding which ones to use and which ones made sense. And I didn't even scratch the surface of everything that could be used. Since then, I've attended some AWS conferences and learned that, oh, well, there's this other service that bridges events and all these different things. So I would say it's all the cloud computing services, and then also just all the different frameworks that are out there. Why did you choose Angular and Bootstrap over framework? Because those tend to be the most, besides React, those tend to be the most in demand right now in terms of web application development. And again, they follow not only multi-platform, they don't not only accommodate multi-platform, but they're also considered single page application frameworks, which means you have basically one HTML page and then you're creating views and routing those views. So it allows for easy transitioning between pages where you don't have like the complete page refresh.
Okay, lots of good questions. Thanks, Amy. That was a really great presentation.
Okay, thank you.
Okay, so up next we have Paul Kim. And Paul, you can go ahead and share whenever you're ready. The title of Paul's presentation is To Remain or To Return, an analysis of Iraqi popular mobilization forces, security impacts on the return of IDPs.
All right, good afternoon from Kansas City, Kansas. My name is Paul Kim, and I'll be giving my MGIS capstone final project presentation on the Iraqi Popular Mobilization Forces and the displacement situation during the post-conflict period of the Iraqi Civil War. Here's the outline of my presentation. To the right is a basic map of the Republic of Iraq for your orientation and reference. And I'll cover my applications of exploratory spatial data analysis and spatial dependence testing in more detail. All right, so here's the background. The Iraqi Popular Mobilization Forces were formed to fight against the Islamic State threat during the Iraqi Civil War. And the PMF is a collective of mostly Shia-based militias that were instrumental in fighting and defeating the Islamic State group in Iraq by the end of 2017. There are other groups, to include the Kurds, that have contributed to the liberation and security efforts in Iraq, but the PMF is uniquely Shia, and they are tied to the sovereign Iraqi government. The total number of Iraqi IDPs, or internally displaced persons, reached 5.8 million during the Civil War. Some PMF militia groups have been cited for human rights abuses, and some are designated terrorist organizations by other governments, to include the United States. And some are expected to be a source of sectarian tensions as they continue to maintain presence and provide post-conflict security in Iraq. Now to the project objectives. My overall expectation and hypothesis was that the increased popular mobilization forces and Islamic State violence was expected to have a negative impact on IDP flow movements and return movements due to decreased safety and security, which means there's going to be more IDP displacement and decreased returns. That is, IDPs not being able to return to their homes after they left the conflict and are trying to return because the conflict is officially over. So my primary objective was to examine linear, correlative, and spatially dependent relationships between PMF-IS conflict zones and IDP returnee movement flows. My secondary objective was to find any indications of the sectarian tension or sectarianism in the conflict displacement variables. Iraqi displacement literature cites subjects stating sectarian tensions and PMF presence in their original district areas as reasons to remain in displacement. And I chose to limit my timeframes to 2 years, starting from 2018 to 2019 and 2019 to 2020. I chose the dates listed above, primarily the February 28 month and day precise dates, because the first available record of returns by the United Nations Displacement Tracking Matrix was on February 28, 2018. That's so a couple months after, well, immediately after the conflict was declared over. I believe that's when the UNDTM started taking account of those returning. And also I chose the end of February 2020 to limit my project study to the pre-pandemic situation in country for Iraq. And so my conflict displacement analytical framework from the proposal to this has evolved, and it consists of all the inputs, procedural steps, and data outputs. The analytical product outputs are depicted by the dark blue bars. The first part of my methodology covers the variable data collection, processing, and exploratory spatial data analysis. IDP return flow and PMF-IS conflict events variables are defined and depicted in matrix notation expression above. Flow variables are distinguished by their deltas and their yearly time spans. PMF conflict events include all conflict events where the PMF was involved as the subject, actor, or supporting actor for the Iraqi security forces against the Islamic State. So those are the operations, events, activities that the PMF carried out on their own against the Islamic State, and also for those in combined cooperation with the Iraqi security forces. Islamic State conflict events are those conflict events in which IS was the subject or aggressing actor. So I used ArcGIS 10.8 for the kernel density estimation from the conflict event point layers, and the vector-based thematic and dot density layers to depict IDP and return distributions and flows. The second part of my methodology consists of applying the conflict displacement variables to an exponential sequence that starts with the standard linear regression model formulas for IDPs and returns through the Lagrange-based diagnostics testing process, and applying respective spatial error and spatial lag models to determine significance and evidence of conflict events impact on displacement. And I will now cover the results of my exploratory spatial data analysis. So here are the PMF-IS conflict events bar plots and linear trend scatter plots for the 2018 to 2019 and 2019 to 2020 years. The first year graphs are depicted on the top row. The second year graphs are depicted on the bottom row. The first year is marked by an increase in Islamic State attacks and PMF response. Note the decreased PMF-IS conflict events of the second year and the several-fold decrease of Islamic State explosives-based attacks in 2019 to 2020. Most IS explosives attacks are remotely detonated IED attacks, and VAC stands for violence against civilians. So after the first post-conflict year, you can tell that the Islamic State has carried out more violence against civilians, and that potentially would have a greater effect on the safety security situation for those IDPs that are in displacement, as well as the civilian population in Iraq. And then for the PMF strategic developments, most of them consist of explosives defusals, weapon seizures, and the actual destruction of IS facilities. So for this slide, I've included the previous PMF-IS conflict events linear trend scatter plot for comparative reference. I provided the first and second year IDP and return flows to depict and indicate the post-conflict initial wave of returns phenomena of the first year, as well as the diminishing returns and increasing displacements of the second year. First year flows range from 0 to 250,000 returns and 0 to 105,000 IDP outflows. Second year flows range from 0 to 125,000 returns and 0 to 200,000 IDP outflows. Districts 36, 46, and 96 are Mosul, Al Ramadi, and Tal Afar districts, respectively, and they are among the most conflict affected areas. And then here are the vector-based thematic distribution maps of IDP return flows for the first year. Note the IDP displacement movements outside the PMF-IS conflict zones and the higher returnee arrival concentrations within the conflict affected districts inside those zones. The zones are marked by the blue and red clouds or kernel density estimation layer clouds on both maps. They're both the same layer, same set of calculations derived from ArcGIS 10.8. The backwash effect provides that returnees tend to come from adjacent surrounding districts of their origin or their original district when they were displaced. Bar plots per arm group and year by province were just included for comparative reference of the distribution of violence. And that's by province and not by district. And also note the lack of conflict affected displacement in the northern Kurdistan districts and the south central Iraq districts on the return flows map. So basically all the areas on the return flows map that are depicted in gray. Here are the vector-based thematic distribution maps of IDP return flows for the second year. IDP outflows are much higher in the heavy conflict zone districts, and IDP outflows continue in other areas. Return arrival inflows have diminished in comparison to the first year, and some returnee registry shifts are apparent by the negative return flow districts on the return map, and those registry shifts are depicted in the tan color. And those shifts may be caused by changes in the security situation and the displacement status of previous returnee arrivals. And moving on to the results of my spatial dependence testing. So for the first year, 2018 to 2019, the linear regression residuals indicate the obvious IDP outflows from districts based on IDP estimates residuals. There's strong evidence of the PMF driving in IDP inflows into conflict zone districts, which means IDP arrivals continue to remain in displacement. Very strong evidence of the IS attacks driving IDP outflows away from conflict zones also supports IS violence as the main driver of displacement. IDP flow dependence diagnostics testing provide that there's no spatial dependence or autocorrelation, and the null hypothesis of no spatial autocorrelation along with the linear regression results are kept. IDP flow is a correlative explanatory variable of return flows and the near one-to-one negative coefficient for the first post-conflict year is an indicator of the post-conflict initial wave of returns phenomena. The spatial dependence diagnostics of both global Moran's I and Lagrange multiplier testing suggest significance in the spatial error model residuals. The return flow spatial error model residuals indicate moderate evidence of PMF driving return arrivals, and the strong significance of the spatial error model result suggests spatial error dependence and existence of additional explanatory variables. The very strong evidence of IDP outflows in the spatial error model also indicates explanatory variables driving higher returns during increased IS violence. The return flow spatial lag model residuals also indicate very strong evidence of IDP flows contributing to higher returns, and spatial lag dependence suggests coefficients are both inefficient and biased per Chi and Zhu's spatial regression modeling. The overall moderate and lesser significance of the spatial lag model residuals indicates that the spatial error dependence residuals should be kept. However, the backwashing effect among returnee arrivals in heavily affected conflict zone districts such as Mosul is observable from the exploratory geospatial analysis. And onto the second year post-conflict, 2019 to 2020. The IDP flow linear regression residuals indicate moderate evidence of PMF conflict events driving IDP outflows away from conflict zone districts. The lack of significance in IS impacts supports decreased violence situation in the second year. The higher negative coefficient and very strong correlative evidence of IDP population estimates against IDP flows indicates higher rates of displacement in the second year. The diagnostics for second year IDP flows indicate no spatial dependence, and the greater IDP departures in PMF conflict zone districts can be partly attributed to the PMF factor. So for the second year, the PMF may have actually been a factor towards continued displacement. The return flow linear regression residuals indicate weak to no evidence of PMF-IS conflict events affecting returns, as well as an overall decrease in the rate of IDP returns to original districts. The lack of significant driving factors to return and no spatial dependence all reinforce the diminishing returns phenomena post-conflict and continued IDP displacement. So my expectation and hypothesis was that PMF-IS conflict events would affect increased displacement and decreased returns of IDPs. Geospatial visualization indicates patterns of IDP outflows spreading away from the PMF-IS conflict zones in both years. The spatial lag backwash effect describes a pattern of IDPs in outer adjacent displacement districts returning to their home districts. Spatial error dependence between first-year returns and PMF conflict events indicate the PMF as a conducive factor to returns, along with unidentified explanatory variables. Linear regression analysis suggests the PMF is a driver of increased IDP displacement during the second year. Salvi's potential theory of delayed effects between armed group actors and civilians during conflict may apply to the first year of increased violence and returns, followed by decreased violence but more displacement, potentially attributed to the PMF in the second year. Increased PMF-IS violence and greater return flows of the first year supports Bradley's theory of variation in impact between conflict events and displacement. My overall hypothesis of increased PMF-IS violence directly increasing displacement and decreasing returns was paired with more complex results of varied impacts and delayed effects. Determining indications of sectarian tensions may require further in-depth study on the delayed effect and shift of the PMF as a conducive factor to returns to an IS aggravated driver of displacement. Iraqi demographic and socioeconomic data sets may be difficult to obtain, but would help substantiate both conflict displacement theories and identify potential explanatory variables indicated by spatial error dependence. Here are the references that here are the key and primary references that I used throughout my project. Bradley and Salvi are the two theories that I used to guide my project along, and the regression models provided by Chi and Zhu. Those also provided the guidance and the format to do my spatial regression analysis. And I received all my conflict events data from ACLED, which is initially authored by Raleigh, among others. and all of the displacement and returns data I had received through the UN migration agency. And I would like to thank Dr. Mark Corson and Fritz Kessler for their guidance and their support in my efforts to start, guide, and do my project. I would like to especially thank Dr. Mark Corson for my writing format, and just to be able to improve myself as a solid standard writer. Writing is not necessarily my writing is something that I always make an effort to improve upon, and my writing style always evolves and changes as I professionally develop. And I would also like to thank Dr. Fritz Kessler for recommendation for Chi and Zhu's spatial regression models book. It was basically the textbook and standard guide to doing my regression analysis, and I intend on using that book for future projects. So pending any questions or comments, this concludes my presentation.
Thanks. Great job, Paul. You already have a question there in the chat. So if you want to, I think to see them, you might need to stop sharing.
Okay, I think you've, okay, question from, I think the first question from Ryan Baxter. Would you make any modifications to your methods if studying different kinds of conflicts or in different parts of the world? I would make different modifications, but as far as taking my methodology, I mean, this is the first time I developed this type of methodology for, several large data sets. And I think if I were to treat my methodology as a bit of a, results Scantron sheet, I would consider it a prototype. And so I would potentially adapt my methodology along with the spatial lag and spatial error models, implementing those through R. And I may consider using other spatial regression models like the spatial Durbin mixed model. That was one model that was available, but I wanted to stick with Chi and Zhu's book as much as I could, and I stuck with or I used Anslin's method and Lagrange's method and Global Moran's I method. And so I may actually, change my methods if I were to use a different project and see what evolutions take place to my methodology. So from next question, Blake Ross. Before getting the book on regression analysis, what was my background with statistics, and what was the learning curve for this project? My background with statistics was mostly the foundation was basically the undergraduate statistics foundational level. I understood all the terms, most of the applications, all the quantitative methods involved in interpreting significance values. As far as the learning curve project for this book, it was like taking on a new and more advanced chapter in your college level or college level math book. That's a good way, or that's an easy way for me to describe it. And a question from Dr. Kessler. As a way to expand or validate your approach, could you consider going back to an earlier conflict like Vietnam to see if the same factors are of note in your predictions? When all the data is, if a more complete data set is available and a complete and large enough sample size of data is available for a historical example like Vietnam, I could. And I could also be able to draw some socioeconomic indicator data that I can implement and potentially in theory, that should actually lower the spatial air dependence by including other relevant socioeconomic data factors and the actual violence. And I'm not sure about the actual accuracy of the conflict events or the inclusiveness of all conflict events that have taken place. There may be some conflict events that go unreported or are included amongst other events, but should be included in other events or in a single event, or should be partitioned, disaggregated in those events.
Oh, Mark
Any further
Portson here. I'm gonna go by voice rather than chat. First off, excellent job on your project. I want to thank Fritz for his because I'm not a tech person, and I can see that you're all geeking out on the statistics. So thanks, Fritz, for taking care of all the parts that leave me cold. Paul, I wanted to ask you, sort of based on intuition, experience versus your spatial analysis and the math. So basically, in the area we're talking about, what was the confessional affiliation or sectarian affiliation of the predominant of most of the population in that operating area? Sunni, Shia, Kurd?
Throughout Iraq, the general ethno-religious composition of the Republic of Iraq, or Iraq in general, is about maybe 60 to 70% Shia, and then 20 to 30% Sunni, and then maybe the marginal less than 10% that are Christians, Kurds, among others.
Okay, so you noted in the northern portion of the country that basically Iraqi Kurdistan was pretty calm. The south, with predominantly Shia, was pretty calm. But the area where ISIS was doing their thing was, is it fair to say it was predominantly Sunni?
Yes, they were. Most of those areas were Sunni areas along the north central Iraq areas, like Mosul, Kirkuk. Those were predominantly Sunni, and that's part of the reason why the Islamic State was able to get in and establish their territorial control and eventually their caliphate. And I think what had happened, and it's not necessarily that those districts or provinces are entirely Sunni or are kind of enclosed in their segregated areas. It's just that most of those were Sunni areas, but there also was, you also had Shias that trafficked through those areas as well, or lived in those areas. And so,
okay, so here's my question for you. So you've got ISIS doing its thing with some support from the Sunnis, but also with pretty serious human rights violations and a very difficult life for people in their caliphate. And then you've got the Popular Mobilization Forces, which are predominantly Shia, coming in along with the Iraqi army to fight ISIS. And so what I'm interested in is conflict generally, it seems intuitive, would drive people away because they don't want to get killed. But you would also think that once ISIS was defeated, you'd see a pretty good rate of return. Yet you have these Shia militias with a predominantly Sunni population. So what I'm interested in is intuitively, I would think that people would want to return, but with the Shia militias continuing to do their thing, that intuitively may or may not be the case. What was your sort of intuitive analysis of that versus what your math and your analysis said, your spatial analysis said about that fact of returns with the PMF forces still operating there after the defeat of ISIS?
I think during that post-conflict transition situation, whether it was actually Sunnis or majority of Sunnis or Shias that were displaced, for those that were unable to go back to their district or original districts, they would all attempt to return, but some of them were not able to return and settle down to settle down in their original home locations because of either the destruction or because somebody else has settled settled down in their original locations. And those, like someone else replacing the original tenants or residents, they may have been sponsored or allowed to live in those areas by the occupying Shia militias at that time. That was one of the things that I had picked up from my literature.
So that's kind of an indirect ethnic cleansing in a way.
I guess another term would be I forget what the term was, but it's more of like a social engineering that's taking place, ethno-religious engineering, reorganization in those areas. So the Shias would potentially scare away or drive away the Sunnis, but allow the more religiously sectarian congruent Shia civilians to come in.
Yeah, sounds like a nice phrase for ethnic cleansing to me, but thank you for that answer. It's very enlightening, and congratulations on your project.
All right, thank you, sir.
Okay, thanks again, Paul. Thanks for all the good questions. We have 2 more presentations, so if everybody can stick around for those and ask some questions in those as well. Our next person who's up is Bill Schwartz, and his title is "Do CCTV and GDT Technology Lower Gun-Related Crime?" So whenever you're ready, Bill, you can go ahead. Bill, we don't hear you yet, so make sure you're unmuted. We're still unable to hear you, Bill. Are you able to hear us, hear me? Maybe leave the room and come back in if that, maybe that'll solve it. Yeah, we're still not hearing you. Not sure what's going on. I'm going to ask you to unmute here and see. But even when I can see you're not muted, we're still not hearing you for some reason. Yeah, I think we need to maybe we'll move on to Travis, and then we'll come back to you, Bill, if we can try to get your audio working. Travis, are you okay with starting now, since that's just a little bit before your original start time anyway?
Yeah, sure, no problem.
Okay, thank you. So you can go ahead and start sharing whenever you're ready. Travis is going to give a talk on third-party damage risk assessment for natural gas transmission pipelines in Santa Clara County, California. Thank you, Travis.
Sure thing. Let me just get set up here really quick. Sharing. Let's start the presentation. All right, yeah, thank you very much. My name is Travis Peterson. My advisor is Pat Kennelly. Hello to everyone, and thank you for your time today. I really appreciate this opportunity to share my project, which is third-party damage risk assessment for natural gas transmission pipelines in Santa Clara County, California. And I am happy to take your questions at the end of the presentation. So this presentation is going to begin with an overview of third-party damage. We'll talk about the gas system and then risk management as well. Then we'll cover the project objective, methodology, results, and we'll close up the presentation with results, some limitations, considerations for future projects, and of course, questions. So a little overview first. This map shows the natural gas transmission pipeline network in the United States. And essentially our natural gas is gathered at wells, it's transported, it's processed, and it's also transported and delivered to customers throughout the country. And we're going to be focusing on California today. So third-party damage is an unplanned event, and it's committed usually by an individual or some organization that really isn't responsible for a utility's maintenance or operations. So telecommunication, electric lines, sewer, water, oil, natural gas pipelines are all examples of buried utilities that experience third-party damage. And so each hour, 10 utilities are damaged by third parties in North America. And there's a mitigation measure out there, right? It's called 811. It's also known as call before you dig, and it's also known as locate and mark. And it's a it's like a national mitigation measure, and you've probably seen commercials, and it's there to prevent damage to third-party damage. Essentially, marks are made on the ground by an operator of a pipeline or some sort of utility, and they indicate the presence and type of underground facilities. So it's really important because there are a lot of buried utilities in the United States. There's approximately 100 yards of utility line for each person in our country. And utility damage occurs frequently when one call is not used by those who perform some sort of excavation, whether it's digging in the ground with an auger, gardening, or more intense construction activity. Actually, a survey by the Common Ground Alliance showed that 50% of homeowners are probably not going to call 811 prior to excavating. And it's a shame because simply calling 811 reduces the chance of damaging utility line to like around 1%. So we have this root cause for third-party damage called notification not made. And this is a root cause that is related to folks not calling 811 or one call or locate and mark. So excavators are not calling this mitigation measure. And it's a major contributor to third-party damage, especially in California. It's the leading cause of third-party damage. In 2018, there were 4,000 incidents that occurred. So why am I interested in this and why am I important? Well, I work in the utility space, and third-party damage can cause explosions, fires, and can lead to loss of life, injury, and financial loss. Third-party damage causes 66% of all gas pipeline incidents in the United States. And my main question was to determine where third-party damage incidents are likely to occur. These images are shocking. The image in the upper right-hand corner is one that I actually responded to as a geospatial data analyst. The sheriff's department built a gun range on top of a pipeline and used that bucket loader to move some dirt around and actually caused a very large explosion. So my objective is to develop a third-party damage risk assessment model for a natural gas transmission pipeline in Santa Clara County, California. So why did I choose this county as the project study area? Well, I performed a hotspot analysis and it indicated that for excavation damage, the county is a significant hotspot in the state. And then also I did an emerging hotspot analysis and it indicated that that county had several emerging hotspots within the county. And so that's why I chose that project area. So let's move on to the data sets that I use in the project. And the data sets are thought to be drivers of third-party damage. So this map shows gas transmission pipeline and third-party incidents. The transmission pipelines are a black polyline and they are an area of interest for the study because that's where damage can occur. The notification not made incidents are shown as orange boxes. These incidents were used to develop the risk model. And then we have dig-ins as well. These are locations where damage actually occurred and they're red boxes. And I use these to compare against the actual risk model that I've developed. And I received this data from a pipeline operator. And then this data set is, this is a map of impervious surface. I got this down, I downloaded this from the USGS, and generally harder surfaces are thought to be more protected than softer surfaces from third-party damage. So asphalt and concrete are a little bit difficult to dig into compared to like dirt and gravel. This is a map of land cover. It shows surface composition, activity type, and even activity intensity. I got this from the USGS, and basically some surfaces are more likely to be disturbed by excavation, and activity intensity could indicate potential for third-party damaging incidents. And this is a map of land use. It primarily shows activity type in an area, and some activity types, again, are more likely to disturb the ground than others. You know, when you think about residential areas or agricultural areas, potentially. Let's see, and this is a map of locate mark frequency. This is that mitigation measure. So where people or excavators have called to have utilities marked. The volume here corresponds to excavation activity, and that could indicate where there's a lot of construction going on, and where third-party damage is probably more likely. And I created this actually by doing an overlap analysis in ArcGIS Pro. And I got this data from the operator as well. This map shows pipeline marker visibility. And I made this through doing a line of sight analysis of pipeline markers and elevation data. The analysis indicates where a marker is visible within about 395 feet of a pipeline on either side of the pipeline. You know, this distance was used because I found a study that indicated it's the maximum distinguishable distance of a pipeline marker from a person. And then, you know, marker placement, it's mandated at specific locations like road, rail, river crossings, but the distance between markers is more influenced by local conditions, whether or not we can safely place a marker or not is like the driving factor there. And then this is a population density at the census block level. You know, population density could indicate an activity intensity for an area. So let's take a look at my workflow to create the risk model. So my data sets on the left-hand side that I just described, they're surfaces, raster surfaces, and I clipped them to the area of interest, again, which is 395-foot buffer around the pipeline. And then I extracted surface values from incident locations in ArcGIS again. I summarized the values at incident locations by surface category, so their attributes, and I developed a scoring index. And then I reclassified those surfaces to a common state scale. Started out with mostly nominal data, and I need to get that data into an integer type scale so I could compare them and add them together. So that was some of the surface prep. And then I did a sensitivity analysis. And my goal here was to determine how each surface contributed to the overall risk score. So this process was basically I established a baseline and I added all the surfaces together. And then I tested each surface one at a time by doing an addition of the surfaces again, but leaving out one surface each time. And ultimately that would give me a score, and it would tell me the effect of that surface on the overall score. And then I constructed weightings. So I had to weight all these surfaces, and I found something called the analytic hierarchy process, and I use this to weight surfaces. It's basically a pairwise comparison, kind of showing in this graphic, where I compared all the variables or my surfaces relative to each other. And I use this method to determine the importance of each surface relative to the rest of the surfaces based on the scores I calculated in the sensitivity analysis. And the last step of the workflow was to perform an overlay analysis and create a third-party damage risk assessment model in ArcGIS. So let's take a look at some of the results. So the thing that I found mainly was that pipeline marker visibility contributed to over half of the weight in the analysis, 53.1%. And that was through the analytic hierarchy process and the sensitivity scores. So this project also found that 60% of all these incidents actually occurred in areas where markers were not visible. So it seemed to be pretty important. When I looked at the rest of the surfaces that I used, land cover, impervious surface, land use, and locate and mark frequency, all 4 of those surfaces added up together were less than 50% of the weighting. And they were all like pretty similar, from 8 to 13.6%. So they all seem to contribute, I guess, the same to third-party damage. And then population density contributed the least amount, actually, at 3.9%, the smallest of all those factors weighted. Yeah, so let's take a look at the risk model. So this is a map of third-party damage risk assessment. And the table in the upper right-hand corner is a summary of risk score with land area and incidents. And so here, a score of 9 is the highest likelihood of third-party damage, while a score of 0 is the lowest likelihood of third-party damage. So let's explore this a little bit. So the score range of 0 to 4, you see that they're all pretty small land areas, and there's absolutely no history of incidents occurring in those areas. So pretty low likelihood that we need to worry about risk there. And then we have the score of 5, which I thought was kind of interesting because it makes up only 14% of the land area in that area of interest that I defined, but it has 22% of the no locate request incidents. So this is where people were actually stopped from performing excavation. 22% of those incidents occur there. Could indicate something. And then the score range for 6 and 7 are similar in terms of land area and incidents that have occurred. And together they make the greatest land area and incidents. But when you look at them individually, they seem less important or less risk than the score of 8, which we'll look at now. It has the greatest land area at 34% of the area of interest, and it has the greatest number of incidents for the no locate request incidents where people were stopped from excavating, and then also dig-in incidents where the pipeline was actually damaged. So it seems like one of the more risky areas to consider for the model, even compared with the risk score of 9. 9. So the score of 9 is like the most risky area within the model. But it has only like 1% of the land area in the area of interest and has a pretty low occurrence of incidents as well. So I guess my take on that would be that it's probably like the highest probability of something happening, maybe not probability, but the highest likelihood of something happening, but it's got a really low sort of land area. So a small area of opportunity. So, not a lot is happening there. So let's take a look at a couple of detailed examples for this risk model and maybe look at some of these driving factors. So I'm going to zoom in this map. And what you're looking at is a map of a developed area here. It's got like mixed use with commercial, residential, industrial areas. So pretty developed. And you see the risk score, and then you also see pipeline markers shown as black dots. So locations 1, 2, and 3 all have risk scores of 8 bordering on 9. And the driving factor here appears to be marker visibility at locations 1, 2, and 3. So you see the pipeline marker visibility of red means that markers are not visible at that location. seems to be the driving factor for risk in this area. Let's take a look at another example. So different kind of land use here. It's agriculture, primarily, with some folks living there. And this map also shows risk score and then the pipeline markers. So location 4 has a risk score of 7, and then you see, to the north west and then the southeast, we see like lower risk scores, and the driving factor behind that seems to be pipeline marker visibility as well. As you can see, location 4 is in an area where pipeline markers are not visible. They're in this indicated by that red area. And then we'll take another look. This is primarily a residential area, pretty dense residential area. We see the risk score again, and then also pipeline markers as black dots. And so location 5 has a risk score of 8, with some score of 9 around there as well. And it looks like the driving factor there is also pipeline marker visibility. Pipeline markers are just not visible, and you can see that in this graphic. So what is my interpretation of this? I think that the risk score of 8 is probably the best area to focus mitigation efforts. It has the greatest land area and it has the most incidents, but also focusing on this area could help drive down other risk scores due to their proximity or their clustering around that score of 8. My results indicate that marker visibility is the most important factor for third-party damage. And I think if we increase marker placement, we could decrease third-party damage, actually. Marker placement could also be improved by evaluating its placement through line of sight analysis. I think I've showed that. And mitigation efforts could be more effective if they were employed by looking at marker visibility. Like we know where the markers are, but maybe in some areas where we don't have as many markers, maybe we should have different mitigation efforts there. The marker visibility analysis was limited to 1/3 arcsecond elevation. And so that's, I think, 10 meter horizontal resolution and 3 meter vertical resolution. And then my analysis results are limited to the county scale. And so I think for future studies and practical applications, we can probably right now determine where markers should be placed to help mitigate third-party damage. I think we can probably update that pipeline marker visibility analysis with vegetation, buildings, and higher resolution elevation. And then also we should probably apply the marker visibility analysis at a regional level. But also I think this analysis that I performed, we should probably perform this at a regional level as well and see if we get the same results. I have a couple pages of references. I read some risk management manuals, and then also read about incidents from the Department of Transportation primarily. And then some other literature were used here too. And I'm happy to take your questions or comments now. I'm going to go ahead and stop sharing. And thank you for your time today.
Thanks, Travis. We'll wait for some questions.
Yeah, sure. Blake asked if I could explain how I chose my area again. There's so much data out there for the state of California and from the USGS that I had to limit my approach to one county, just for the sake of having the processing power and the capability to work with that much data. So I chose to go with a county scale because I thought it was something that was manageable. And then also I used ESRI 10.4.1 optimized hotspot analysis with the incident data to determine, where in California there was some significant hotspots for excavation damage. And so that's how I got to that area. Fritz asked this, a very interesting prompt. Okay. huge safety impact. Extending your idea a bit, could you think that including the type of utility as a risk would be any benefit in the weighting scheme of 36-inch gas main has a higher risk damage? Oh yeah. Yeah, I did think of that. And I guess you would say that the incidents that I were investigating and used to develop the model were from the pipeline. Well, we're from a federal regulatory commission and also an operator, and the incidents were primarily focused on pipeline damage. And coincidentally, there isn't a lot of data about other type of utility damage that I could get my hands on. But I think that would be, very telling if we could actually get incident data by type of incident and look at it that way. It'd probably be much more effective in discerning where we could focus mitigation efforts for other utilities. Yeah, thank you for that.
Okay, thanks again, Travis. Great talk. I guess in the interest of time, we'll move on. If any other questions do come in, maybe you can follow up with an email. And we'll now try to see if Bill's audio is working. Bill, you want to give it a shot?
Can you hear me?
Yes, we can hear you.
Okay. All right, good afternoon, everyone. I'm Bill Schwarz. I work as an irregular warfare analyst for an agency under the Office of the Secretary of Defense. This is a presentation on my research project titled Do Closed Circuit Television Cameras and Gunfire Detection Technology Lower Crime, Gun-Related Crime? My advisor is Dr. Greg Thomas. Here's my agenda and what I'll be going over. I'm not going to go over the lighter shaded stuff. I went over that in the proposal, and I want to move on. My research questions: is there a reduction in gun crime in an area surveilled by both closed circuit television and gunfire detection technology as compared to an area not under surveillance? And are these technologies optimally located? For those that were at the proposal, just to refresh, and if you were not at the proposal, these are what the different systems look like that are employed in the District of Columbia. Top left, we have the CCTV cameras. And then if you're not familiar with it, the gunfire detection technologies in the upper right and lower left. These are sensors that are placed around the District of Columbia to detect gunfire. And then there's a mobile system, not necessarily employed in the district, but this system triangulates the gunfire by the sensors on this one array, where the other sensors require multiple sensors to triangulate gunfire. These are my data sources. They're publicly available at the Office of the Chief Technology Officer and the Metropolitan Police Department. And through a series of ArcMap GIS applications, operations, what I'm trying to do is narrow down my areas into a control area and a treatment area. The treatment area being covered by CCTV cameras and the gunfire detection sensors, and the control area not. And what we're looking at on the right-hand side here is we have a camera location, and then surrounded by gunfire calls for service. Someone picked up the phone, said there's a problem with a gun here, or the gunfire detection technology. Expected outcomes, when used together as part of a policing program, closed circuit television and gunfire detection technology will reduce crime in a targeted area when examined using GIS spatial technology. All right, limitations. My study is limited to one census tract within the District of Columbia, and there are 50 census tracts per the US Census. I did not choose the boundaries. They're man-made boundaries, and I am using what already exists. And there is the possibility that other agencies possess gunfire detection technology, and they definitely have cameras. Other agencies definitely have cameras in the district. The other agencies with the gunfire detection technology would require a Freedom of Information Act. I did not pursue that. I'm only looking at the District of Columbia's jurisdiction and what they control and in their areas. Information gaps and key assumptions go hand in hand here. Gaps in policing strategy, Maryland police leadership, I did not take into account. So the assumption is those personalities, their strategies, that remained constant throughout the time frame of the study area. And the data ranges from 2014 to 2019. The economy. My assumption is the economy had no effect on crime. So if times are tough, you know, people resort to drastic measures, possibly even violent measures, and compete for limited resources. I'm saying that throughout the study time frame, everything was consistent. Population movement. I know there's another student that's examining gentrification in the district. I'm saying that for my study, the population was stagnant. There was no movement into and out of the area. Everything was the same throughout the study time frame, 2014 to 2019. All right, just to orient you to my study area, I've narrowed down the area I'm looking at into Ward 8. So this is Ward 8 right here. We have the Potomac River in the west. Up in the north, we have the Anacostia River. Over to the northeast, we have Ward 7. Down to the southeast, all along here, this is the state of Maryland. Farther to the west, we have the state of Virginia. This pale pink area right here is Joint Base Anacostia Bowling. And we have Interstate 295, a spur that comes through the Ward 8 area. I've narrowed down my study and control, or my treatment and control areas. My control area is this area in green right here with a mean income of $33,000 a year. And there are 8,000 residents in the area approximately. I think it's 8,080 or something like that. My treatment area over here, $27,000 is the mean income. And there are approximately 10,000, it's more like 9,600 folks that live in the area. And why all this is important, we want to get a treatment and control area that are relatively close to each other, but we don't want the control area to be affected by what's called a halo effect. If I treat this area with cameras and gunfire detection technology, I don't want the crime to just move out and be in the surrounding area here. I want this area to be far enough away so that by placing treatment in here, it may not affect this area. And the background is important because according to Brantingham, and Andreessen, who have a decade's worth of crime pattern theory under their belts, they speak of Rule 1, the backcloth matters. So everything that goes on in this area matters as far as crime is concerned. And I know some of the professors have a military background. You know, if you're familiar with some of the other analysis, backcloth sounds the same as A-scope and dime fill. Dime fill is now midfield because they've added another D to it, and PMISI PT. So all of these are things that examine an area and take into account of the overall situation that's taken place there. So just, I did some time-space data mining just to see what was going on in the area. So not to say that there's no crime going on in the control area, because there is a little bit of gunfire there, but not sufficient to basically show up in the parameters that I've set for the time-space data mining. And the time-space data mining criteria I used were 1,000 square feet, based on my review of literature, which 500 feet was the buffer, was the camera radius. So I just took that and squared it, made it 1,000 by 1,000 for my search area. And my temporal search area in the space-time data mining was 1 month. I felt that was sufficient to give me enough time bins, whereas if I just went by the year, I wouldn't have enough time bins. And what it shows is there are sporadic hotspots in the treatment area, both with calls for service. Somebody picked up the phone and said there's a problem with a gun here, or gunfire detections. And we didn't see any patterns in the control area. And same thing with trends, we didn't have sufficient data to trigger anything in the control area, but we do have some trending of data in the treatment area. Treatment area, again, being in the black outlined area. And the circular areas within the treatment area are your camera buffers. There are 5 cameras in the treatment area. So findings. The control area consisted of 130 acres with no cameras compared to the treatment area, whose overall for the census tract was 314 acres, 69 of which were covered by 5 camera locations. So in the control area, we have 28 calls for service. Someone picked up the gun, said, picked up the phone, I have a problem with the gun here. And 33 calls for service in the treatment area. Shot spotter detections, many more in the control area with 92. We look at the shot spotter detections in the treatment area, and this is that 69-acre area, 796 detections, 2014 to 2019. So just think about this, 719 detections. 3 of these camera locations are around elementary schools, not taking into account the length of the school year, how much time a child is sitting in class. But think about this. If you're a child in a classroom, potentially once every 12 days, you can hear a gunshot within 500 feet of your classroom. Just something to think about. The control area, we saw almost a 10-fold increase in detections in the first year that it was employed. And the control area comprises 22% of the acreage of the census tract. And there were 57% of the gunfire detections took place in that area. And again, a lot of that is around 3 elementary schools. There was a 43% reduction in detections in the camera area and a 51% reduction in calls for service in the camera area. We did notice between the control area and the treatment area, there was a recurring 3-year pattern. Now this is 4 years right here. I'm showing 2014 to 2017. So if we looked at 2014, took 3 years, and it continually went down. 2015, it continually went down. That was the only pattern that I saw in the control area with detections. In the treatment area, the recurring pattern occurred like 3 times over during that period. So first year of that 3-year period, we had a spike in detections. It continually went down for the remaining 2 years. And then in that, what would be the 4th year, started the next 3-year pattern, the shots went up again. And then they continually declined, and we saw that 3 times over. Now, the 3-year pattern did not align between calls for service or detections. So don't really know what that means, although 2 different data sets may have something to do with policing strategy if the periods lined up. However, they don't line up. And just to go back to this 22% of coverage for the camera coverage, if you note at the bottom, Branningham's crime pattern theory in the back cloth, sorry, someone's hit the door. So we have this 22% of acreage that 57% of the crime is taking place in. So Brantingham makes note of in Rule 2 that there's things that are going on a routine basis. And granted, we know that those are elementary schools, but gunfire doesn't typically happen at elementary school. So what we'd have to explore further is what is going on around those elementary schools that is attracting all this gunfire. All right, conclusions. Is there a reduction, this is back to my research questions, is there a reduction in gun crime in an area surveilled by both closed circuit television and gunfire detection technology as compared to an area not under surveillance? So gun crime was not necessarily reduced, but rather new crime was detected. In 2-camera buffers, there were no calls for service. So no one picked up the phone and said, I have a problem with a gun here. But yet in 2-camera buffers, there were 45 and 85 shot spotter detections. So this supports the current knowledge on gunfire detection technology in that gunfire is underreported. Since the start of its use, shot spotter detections declined from 2014 to 2019 in both the control and the treatment census tracts, as well as the camera buffer area. So the decline across the control and treatment areas may be indicative of factors which would influence the use of a firearm. So this also supports the current knowledge base, but also it adds to that because previous studies did not take into account a control area. Are these technologies optimally located? CCTV and ShotSpotter appear to be appropriately positioned within the treatment area, in that the camera coverage was able to, limited camera coverage was able to capture 57% of the gunfire-related crime. Though a large amount of crime takes place in the area treated with detection and surveillance systems, this does question the effectiveness of these systems to deter crime on their own. So again, it goes back to, is there an overarching policing strategy that may be in effect here? Recommendations. Consider a micro-terrain and human terrain analysis of the 22 acres containing 57% of the gunfire detections. Why is that area high in detections and what's driving the crime there? And also the study areas in close proximity to the Washington, D.C. and Maryland border. Do policies on gun ownership between the two affect crime? Do perpetrators tend to be marauders? So those folks who may live in the area and just, roam around their neighborhood committing crime? Or are they commuter criminals who, get in a car, take a bus, take a train, go to someone else's area and commit a crime? And so both of these two statements have to do with Brantingham and Andreessen's rules 3, 6, 7, and 10, where they talk about not just that it's occurring there, but why is it occurring there, and what sort of uses, in addition to what may be the planned use of an area, what has it become based on the inhabitants? What have they turned it into? And so then I would say if we answer some of those questions or address those rules, then you can go into Rule 5, which to me is a social network analysis and a friends of friends type of research, where if my friends are criminals and they're doing this, am I going to do that? Or, is someone, am I doing that because they're doing that, or are we all doing it because all of us are doing it together? So that's all I have. And any questions?
Thanks, Bill. There's already a couple questions in the chat. Great job. You might need to stop sharing to be able to see them.
Oh, I can see it. Yes. So is the shot spotter technology sophisticated enough to differentiate gunshots and other sharp, loud sounds? And are there false positive gunshot IDs that you had to deal with? So it can differentiate between fireworks. Now there are false positives, and believe it or not, it was not that many, and I did not use those. Are there physical signs indicating that this technology is being used in these areas similar to signage? So there is signage for the CCTV cameras. I'm not aware of signage for the gunfire detection technology, though. Do they tell you how many arrests were made through the help of ShotSpotter? Not that I'm aware of, but just for background, there were almost 40,000 detections. So I'm pretty sure they don't have the time to address each one of those.
Okay, well, unless we see another question come in here in the next couple seconds here, thanks, Bill, and thanks to all of the presenters today, and thanks to all the participants who came and asked questions and watched the presentations. We have our next session of these next Tuesday, so if you would come back and watch. I think there are 5 more presenters next Tuesday. Then we have the following Tuesday after that, and then this Thursday of that same week. So again, your participation is really appreciated. All of these students will be graduating in May, so they're very close to being done. So yes, great job to everybody, and hope to see you next week. Thank you.